Alright guys, I'm back here. Hopefully you've worked through a couple of these problems. They are a bit of a fight, as you see here, the octagon. They're in the octagon here fighting. They're a bit of a fight in the beginning. As we said a minute ago, or on the previous section on here, you should have a 36-degree angle here. Again, that comes from the previous central angles we found. We got those by dividing the number of sides by 360, and then this little pothom was cutting that in half. So now, once you've got this actually radius is 2, you can apply this formula once you find the apothom and find the perimeter, but you can't find these unless you can do the trig to get you there. So this is your apothom. Your perimeter comes from finding this piece and then doubling it and then multiplying by 5 to get the entire thing. So it's a multi-step problems. I found last year a lot of people got the hang of this pretty quickly, but there's a learning curve to it. It takes a little time to get there. I'm going to jump to another slide with these two. Same two problems. I've just taken these two off of here and done them on a different slide here. So you can check some work on here. I believe there's my apothom. I just threw it up there, little a. I'm going to call half of this little piece x. I'm going to call this little piece x. As you work through it, I think this ends up being 1.176. I think if you use a sine ratio, you can get that value. And I believe the apothom, if you use a cosine ratio, ends up being 1.62. That's my cosine equation, because the apothom is adjacent to that. And I believe that x is 1.76, either using Pythagorean theorem or using a sine ratio to get that. Again, once you have this one, you double it to get the entire side, multiply by that value by 5, because there's 5 sides in a pentagon. I believe you should get a side length of 2.351, and of course a perimeter of 11.76. Then you're going to plug those values into that formula. 1/2 the apothom times the perimeter. So my apothom times my perimeter. Don't forget to divide by 2. If you end up with something that's 19, it's probably because you forgot to divide by 2 at the end. So there's the area, 9.5 square units. Let's try out the hexagon, which is a very common figure for architectural structures. You see gazebos a lot of times that are hexagons. I think there's one over at Browns River Middle School right now. I think there's a sandbox over at Jericho Central School, actually. Has the same type of figure on there. So, again, you're going for the apothom. I think at this, you'd probably use a cosine ratio again, a tangent ratio, actually. Adjacent and the opposite sides are the two that you're kind of working with on that case. This one's a little easier than the other ones because I actually gave you this little piece. The entire side would be 10. I think that's what I gave you on the top. This entire side was 10, which means this little piece is 5. So this one you kind of have to work the other direction. I gave you this before was 10. You realize the apothom cut that in half, and that's 5. And now you can use a tangent ratio. I believe the apothom is 8.66, which kind of makes sense. It should be rad 3 times as big as the 5. And then from there, it's pretty simple. Perimeter 60. That was an easy thing to calculate on this one. Plug values into this thing. All you really had to do for work on this was find the apothom, multiply by your perimeter. I think you get an area of around 260, just a little bit less than 260, so 259.8 square units. Now, if this is on a test, which it certainly will be, I'm going to ask for like 4 parts. I'm going to ask the apothom as 1 answer. I'll ask for the perimeter as 2 answers. I'll ask for the area. That might be a 3-point problem. So make sure you show all your steps on your homework. Don't just give me this and say my calculator did the work. That's great. You did the work. Show me all those steps on there. So I will ask for this on a test. I'll ask for these individual parts of the problem. And a lot of people get this wrong, but they'll get these 2 things right, so they'll get 2 out of 3 points on a problem. So just be in the habit of showing all those steps on there, trig steps, algebra steps, Pythagorean theorem steps on there. Here's the assignment. It's out of the book. This is due. Of course, this is an old thing. Don't ignore that. Scribble that out. Not due Thursday. This is, I thought it might be due Thursday, but this is going to be due on Monday. The Monday I get back, which I believe is April 7th, I think. It's the following Monday. You should be watching this on Thursday or Friday this week, depending on what day you took the SBAC test, what grade you're in. Like it says here, sketch each one of these, and a quick sketch and a label of dimensions on here. 3, 4, 5, 6, 7, 8. It's 9 problems. Not a ton of problems on there. Like I said, it's not due Thursday, it's due Monday. Check Schoology. It is a little tricky. I strongly suggest you check the odds in the back so you can verify you know what you're doing. and really emphasize showing your work. Good luck. I'll see you in a little bit. Maybe we'll give you a quiz next time I see you. No, we won't do that. Thanks for your patience, guys. I'm really looking for feedback again of how well this is working. I think this is one of the hardest units to do without being able to ask questions. So pause, rewind, ask Mr. Snyder. He certainly is an expert on this. He knows this very well. He's taught geometry before. I do think this is one of the hardest units to learn without somebody kind of clarifying your questions. There's probably a ton. I get more clarifying questions on this section than I do anything else in this chapter. So, I apologize for that challenge. But feel free to ask questions on Monday or work with Mr. Snyder while he's there. He certainly will help you. Thanks.